Hello my dear students, once again I welcome you all. So today we are going to see our lecture number 19 and the topic is numerical problems on Euler's formula. My name is Sudhir Kumar, a lecturer in mechanical engineering from James Polytechnic College, Aurangabad, Bihar. So first of all we will see what are the effective length of the column. See, if both ends will be hinged, then effective length will be equal to L. So if the value of L will be given, then we can write as L is equal to LE. And the buckling load formula will be P is equal to pi square EI divided by L square. So buckling load formula will be same for all, but instead of L, we have to write some different values such as C. For both ends fixed, LE is equal to L by 2. If one end fixed and other are free, then LE means effective length will be equal to 2L. If one end fixed and another end hinged, then LE will be equal to L divided by root 2. Understand? So these are some formula, or these are some you can say that some formula, you can say that which we can use during solving numerical problem. So in previous questions we have seen if both ends hinged, then LE were equal to L. So directly what we did there, directly we substitute L values and we got the answer. So today we are going to see one more problem on the topic Euler's theory. Understand? So let's start. So today's question is I will write question for you. A solid round bar round bar of moment of inertia a solid round bar of moment of inertia 30.68 into 10 to the power 4 millimeter power 4 and 3 meter long and 3 meter long with Young's modulus 2.0 into 10 to the power 5 Newton per meter square. Understand? A solid round bar of moment of inertia 30.68 into 10 to the power 4 millimeter power 4 and 3 meter long with Young's modulus 2.0 into 10 to the power 5 Newton per millimeter square. Understand? Find the crippling load and the crippling load. Understand? When the given start is used with the following condition. the following conditions. First one end of the strut is fixed. One end of the strut is fixed and other end is free. This is the first condition. Then second condition is both the ends of the strut are fixed. And the third condition is one end is fixed and other is hinged. One end is fixed and other is hinged. So this is our question, my dear students. What our question says, a solid round bar of moment of inertia 30.68 into 10 to the power 4 millimeter power 4 and 3 meter long with Young's modulus E is equal to 2.0 into 10 to the power 5 Newton per millimeter square. Understand? Then question says find the crippling load when the given strut is used with the following condition. So in this question we have to find crippling load for three conditions. The first condition is one end of the strut is fixed and other end is free. First condition is one end is fixed and another end is free. And the second condition is both the ends of the struts are fixed. That means both the ends are fixed. And third condition, what we have to find? We have to find the crippling load. In third condition, the condition are given as if one end is fixed and another is hinged. Understand? So we have to find all the three conditions of crippling load. So let's start with our given data. First we will write our given data, then we will start our question. So our given data are, first I will write given data. So our given data are L is equal to 3 meter. If we will convert meter into millimeter, then it will become 3000 millimeter. Then moment of inertia value is given, I value is given. How much it is given? 30.6 into 10 to the power 4. 30.68 into 10 to the power 4 millimeter power 4. Moment of inertia value is given. Then what else is given? Yes, the value of Young's modulus is given. How much? 2.0 into 10 to the power 5 Newton per millimeter. These are the given data which is given in our questions. Now what we have to do? We have to find the crippling load under different conditions. We have to find the crippling load under different conditions. So let's start. First we will do our solution. We will start our solution. So first we will start with our condition 1. What is our condition 1? If one end of the strut is fixed, one end of the strut is fixed and other end is free, and other end is free. This is our condition 1. So we have to find the first condition, crippling load. So condition 1 is given, one end of the strut is fixed and another end is free. So what is the formula? Actually, what is the formula to find the crippling load? First of all, we have to write the formula to find crippling load. So we know that, crippling load P is equal to, what is the formula? Crippling load P is equal to, what is the formula? Pi square E into I divided by LE square. This is our formula to find crippling load. This is our formula to find crippling load. What is the formula? P is equal to pi square E I divided by LE square, where pi is pi and E is equal to Young's modulus, I is equal to moment of inertia, and LE is equal to effective length. But as we know that only length is given. Length is given 3 meter. That means 3000 millimeter. But effective length is not given. So one formula is there. As I told you, one tabular column is there. For what? For all the condition. If one end of the strut is fixed and another end is free, if one end of the strut is fixed and another end is free, then the value of LE will become 2L. Understand? Then the value of LE will become 2L. Value of LE will become 2L. Under this condition. So that's why I told you, you have to remember all the conditions value. See, only one thing you have to remember. This formula will be common to all the questions. But what you have to remember the end condition effective length value. Because in some condition, if suppose that if both end will be hinged, then LE will become L. Effective length will become length. But when one end of the strut is fixed and another end is free, then our LE value will become 2L. Understand? Our LE value will become 2L. So what we have to write? Instead of LE, we will write 2L. 2L square. Understand? So now we are going to solve this. So according to our problem, our formula will become now P is equal to pi square EI divided by LE square. So instead of LE, what our value will become? LE will become 2L. LE will become 2L. So 2L square. Why LE has become 2L? Because if one end is fixed and another end is free, then the value will become, see, LE value will become 2L. That's why instead of LE we have written 2L. So now according to our formula, our new formula will become P is equal to pi square EI divided by how much? 2L square. So 2L square will become 4L square. Understand? Now what we have to do? We have to substitute. This is L value. Don't get confused. This is L value. So now what we have to do? We have to substitute all the values in this formula. We have to substitute all the values in this formula. Understand? Now we are going to substitute all the values in this formula. So now we will substitute all the values. So P will be equal to pi square What is the Young's modulus value? 2 into 10 to the power 5 into what is the I value? 30.68. 30.68 into 10 to the power 4 divided by 4 into L square. What is the value of L is given? 3000 millimeter. So if you will solve this equation, put in your calculator, please solve it. Solve it. So if we will solve it, then our value will come 16822 Newton. 16822 Newton, or if you will convert it into kilonewton, then it will become 16.822 kilonewton. This is the crippling load for one end is fixed and another end is free. ये हमारा क्रिपलिंग लोड का वैल्यू है कब? जब एक एंड हमारा फिक्स्ड है और दूसरा एंड क्या है हमारा? फ्री है. समझ में आ गया होगा. एक हम लोग बना लिए हैं, एक हम लोग सॉल्व कर लिए हैं. अब हम लोग दूसरा सॉल्व करने जा रहे हैं, दूसरा कंडीशन के लिए. एक कंडीशन हम लोग का कंप्लीट हो गया. नाउ वी विल सॉल्व अनदर कंडीशन. नाउ वी आर गोइंग टू सी आवर कंडीशन 2. Actually, totally there are 3 conditions we have to solve. So already we have solved one condition. Now we are going to solve for second condition. If both the ends of the strut are fixed, both the ends are fixed. यदि दोनों एंड हमारा फिक्स्ड है तब हम लोग सॉल्व. चलिए इसको सॉल्व करते हैं. तो जैसा हमारा फॉर्मूला है, फॉर्मूला हमारा सेम रहेगा सबके लिए. As we know that crippling load P will be equal to pi square EI divided by LE square. This is our main formula, so don't forget the main formula. But in this condition, if both ends are fixed, then what we have to do? We have to remember the end condition of the column. If both ends are fixed, then our effective length LE will become L by 2. If both ends will be fixed, then our LE value will become L by 2. Understand? Because in your question they will not give the effective length value, they will give only L value, length value. So to know the LE value, we must know the end condition of the column. So if both ends are fixed, then LE value will become L by 2. Understand? LE value will become L by 2. So now our new formula, according to this LE value, we will put L by 2. So our new formula will become P is equal to pi square EI divided by L by 2. Understand? L by 2. L by 2 square. L by 2 square. So our formula will become 4 pi square EI divided by L square. If you will solve this equation, then our formula will become 4 pi square EI divided by L square. This is our new formula. Understand? This is our new formula. So now we are going to substitute all the data, all the values in this formula. So 4 pi square into E value is 2 into 10 to the power 5 into I value is 30.68 into 10 to the power 4 divided by L square. L square is, L value is 3000 millimeter. 3000 square. Let's put in your calculator. So final value P is equal to, put in your calculator. So the final value will become 269,152 Newton. Understand? That means if we convert it into kilonewton, 269.152 kilonewton. This is the crippling load value for what condition? If both the ends will be fixed. If the both ends will be fixed. See, what you have to remember, only you have to remember the effective length condition, effective length value. See, here effective length, LE value will become L by 2. In previous case, what LE value becomes? In previous case, LE value becomes LE is equal to 2L. So here LE value becomes L by 2 because both ends are fixed. So now we will solve third condition. So our third condition is one end is fixed and another is hinged. One end is fixed and another is hinged. So same formula we will apply. As we know that crippling load P, what is the formula? Pi square EI divided by LE square. This is our main formula. But now what we have to do? We have to apply the end condition formula. So here one end is fixed and another is hinged. Here one end is fixed and another is hinged. Then LE value will become L by root 2. If one end is fixed and another is hinged, then the effective length value will become, LE value will become L divided by root 2. Understand? So now our new formula will become P is equal to pi square EI divided by, instead of LE what we have to write? L divided by root 2 square. So it will become, so what it will become? 2 pi square EI divided by L square. Now we will substitute all the values in this formula. So 2 into pi square into, what is the Young's modulus value? 2 into 10 to the power 5 into, what is the moment of inertia value? 30.68 into 10 to the power 4 whole divided by, what is the L value? L is 3000 millimeter. So 3000 square. So finally we will get P is equal to 134. Put in your calculator, 576 Newton. That means if you will convert this into kilonewton, then P will be equal to 134.576 kilonewton. This will be the value of crippling load. So we have solved all the three conditions of crippling load. First we have seen if one end of the strut is fixed and another end is free. So in that condition what we have applied? If one end is fixed and another end is free. So in that condition what we have applied? LE is equal to 2L. And second condition, if both the ends of the strut are fixed, then we have applied LE is equal to L by 2. And when one end is fixed and another end is hinged, then we have applied the effective length LE is equal to L divided by root 2. ये तरीका था हमको न्यूमेरिकल प्रॉब्लम सॉल्व करने का. आपको यहाँ पे मेन फोकस क्या करना था, जैसे कि आपको हम प्रीवियस लेक्चर में भी बताया, आपको याद क्या करना है, आपको इंड कंडीशन याद रखना कॉलम का. चार ही तो इंड कंडीशन है ही. एक इंड कंडीशन यदि दोनों इंड हिंज्ड रहेगा तो एल के बराबर हो जाएगा. यदि एक फिक्स्ड है दूसरा फ्री है तो एल इक्वल टू 2L हो जाएगा. और एक तीसरा क्या है, यदि दोनों फिक्स्ड है एल L by 2 हो जाएगा. और यदि एक फिक्स्ड है एक हिंज है तो एल हमारा L by root 2 हो जाएगा. तो ऐसे करके हम लोगों ने सारे फॉर्मूला को अप्लाई करके बहुत ही सिंपल तरीका से ये न्यूमेरिकल प्रॉब्लम को देखा. So my dear students, if you want to gather more knowledge about the particular numerical problem, then you can refer these two books. First book is Strength of Material by Dr. R.K. Bansal, Dhanpat Rai and Son publication, and the second book you can refer is Mechanics of Solid by R.S. Khurmi, S. Chand publication. So I hope you all must have got a clear concept about the problem Euler's theory. Understand? So we will meet you in next class. Thank you.